So, WEP was the security component introduced with 802.11. Again, it was riddled with flaws. We'll be talking about those flaws. Some of the problems that we saw with WEP. First, let's talk about the WEP key. The access point and every client in the cell, that's every client that wants to associate with this access point, uses the same key, the same exact password. This would be like having a corporate network with 1,000 user accounts and all 1,000 users had exactly the same password. What's the point? Anybody can log on using the other guy's password and we'll never know who it really was. In addition, it's the same password used for authentication, the same WEP key used for authentication that is used to encrypt the data flow. So now I'm using this for two purposes. First, if you know the password, you're authenticated. Also, when you do get authenticated and associated, now you're going to use that same password as the encryption key for all data flow. And because of the weakness in the challenge handshake authentication that we saw just a moment ago, if I challenge you for authentication, you see the plain text, the resulting ciphertext, you now can crack the key that authenticates you and decrypts all wireless transmissions for the cell. So WEP had many problems along this line. To take this a step further, there was no way to change or rotate those keys. We all know we should change our passwords on a regular basis. There was no good way to change these WEP keys other than send out an email to everybody and say, please rotate your WEP key, the new password is going to be this. Well, if the bad guy's paying attention, the bad guy is going to catch that transmission and he's just going to roll along with the password change just like everybody else. It required a manual key exchange or rotation, and this was always problematic. Several more vulnerabilities in WEP. As we're doing encryption with WEP, again using the same WEP key, we would add another variable into the equation called an initialization vector, or an IV. Unfortunately, when the guys who wrote WEP implemented WEP, they used an initialization vector that was only 24 bits in length. Now with 24 bits, I have about 16 million different combinations. This means that with every packet I send, I rotate the key, and that says I have 16 million packets that can be sent before I have to start reusing these initialization vectors. When a bad guy records enough information that he sees the reuse of an IV, he now can subtract that as a variable. It's now not variable between those two frames, and the only variable left is the WEP key. So this led to an attack directly upon the WEP key and makes it very easy for a bad guy to crack the WEP keys, now authenticate, associate, and decrypt all data for the cell using the WEP key that is legitimate. Another vulnerability with WEP. WEP uses a symmetric key stream cipher called RC4. Now RC4 is an excellent algorithm. It's an excellent cipher. The problem was it being a stream ciphers are very difficult to implement properly. And again, I indicated it was the wireless guys, the wireless engineers, that were writing WEP. Well, they weren't cryptographers. You need a cryptographer to write a cryptographic system. And unfortunately, they implemented this RC4 in not the most secure fashion, which introduced additional vulnerabilities in the RC4 process. As I indicated, WEP uses an algorithm called RC4 to do the encryption. RC4 is a symmetric key stream cipher, and it uses a key stream generator. The key stream generator takes inputs that are the key and the initialization vector. The key, of course, is the WEP key, the password that is shared between the clients and the access point. Then the initialization vector is generated from those 24 bits we discussed a little earlier. So the keystream generator uses a pseudo-random number generator combined with the key and the initialization vector to create the key stream. Data, the plain text data that we're encrypting, now gets exclusive ORed with the key stream bit by bit to produce the ciphertext. Yet another weakness with WEP is its weak integrity validation checks. WEP uses a linear CRC function that is directly related to the data, and this is one of the weakest forms of integrity validation. As we implement 802.11i, it solves these problems by using cipher block chaining message authentication code, CBC MAC. And this is a much stronger form of integrity validation. So let's look at a quick list of some of the security issues related with WEP. This isn't a complete list, but this is enough. First, the initialization vector is short. The cryptographic keys are too short. Everyone in the cell uses the same cryptographic keys. These cryptographic keys are not only used for the encipherment of the data, but are also the passwords used to authenticate the users in the cell. So the key is used for two purposes, not just one. The keys have no easy way to be rotated. We would have to contact each individual user in the cell, identify what the new password is, the new WEP key is, and then everyone would have to manually update their WEP keys. This then would also have to be performed on the access point itself. And while RC4 is a very strong encryption algorithm, it was improperly implemented in WEP because the guys that built WEP weren't cryptographers. They were radio frequency engineers. There are many other weaknesses that go along with WEP. This is just a partial list. Another vulnerability with wireless technology, and this is a problem with all wireless technologies, is the management of the cell. We call this cell shaping. Now this is probably your weakest form of security regarding wireless networking. However, it's still a component that should be considered. You should shape your cell to cover only the area of interest. Don't propagate 50 yards out into a parking lot or out into the street. This is where bad guys can sit in a van and be stealing your wireless signal, trying to break into your wireless network, stealing information, compromising security, etc., etc. So again, you use directional antenna, you properly place the antenna, you perform surveys to identify and analyze where your signal is being propagated. And all this said, with a good strong antenna, a Yagi antenna, etc., very often the signal can be picked up from as far away as 5 or even 10 miles. So all the work you're doing on cell shaping, this is only to knock down the unsophisticated hacker. But if a guy really wants to steal your signal, he'll get your signal. Again, cell shaping should still be considered and should still be implemented.